we're going to graph this exponential function, and we're not going to do it by transformations. There are a lot of transformations going on here. If I were to count them, I mean, look at this. We've got a vertical reflection, a vertical scaling factor, a horizontal reflection right here, a horizontal shift, a vertical shift. There's a ton. So you could graph it by transformations, but it's kind of a lot of work. There's a much quicker technique. We're just going to use key features. We're going to focus on a couple key points that let us graph the whole thing. The first of those that you just got to know this. Where is the horizontal asymptote in an exponential equation? Well, it's just sitting there, right? It's the plus whatever number. Okay, that's your horizontal asymptote. You have to know that exponential equations have a horizontal asymptote because ultimately every exponential looks kind of like COVID cases back in 2019, 2020. Starts out small and then skyrockets. Okay, that's what exponentials do. That's why they call it exponential growth, because it's going crazy. So our horizontal asymptote is y equals 6. It's just whatever that number is. And if it were minus 6, it would be y equals minus 6. So I'm going to plot that on this graph. Okay, there's my asymptote. And the function itself is going to be found using some key points. And I just need 2 key points. And you can guess x numbers, right? You literally can just sit here and say x equals 0, what's y? X equals 1, what's y? I don't love that way because every now and then you get a number that's not great, like a billion or something, because these are exponentials. They get big. Instead, what I'm going to do is I'm going to take that exponent and set it equal to something that I know will be really nice, 0. Because I can take 4 to the 0 power and it's a nice number. So if I do this, I'm going to bring x to the other side, and that gives me x equals 1. Well, now let's plug that back into the equation. I'm going to say f of negative 1, right? I'm going to put x to negative 1. That makes this negative 3 times 4 to the negative 1 minus negative 1 plus 6. Well, let's simplify that. I know it looks a little complicated, but it's not that bad. Negative 3 times 4. Now, 1 minus negative 1 is just negative 1 minus negative 1 is negative 1 plus 1, which becomes 0. That was the design of this. We wanted the exponent to be 0. So this becomes negative 3 times 1. 4 to the 0 is 1 plus 6. And that's just negative 3 plus 6, which equals 3. Okay, so now I have some x and y values. There's the x, there's the y. And I'm going to put this in a coordinate point, negative 1, comma 3. Okay, that's my key feature. It's just as important as, well, maybe not as important, but it's important. You can't graph it without it. So I'm going to plot that right about here. Okay, negative 1, comma 3. And then I'll do the same thing. I'm going to set the exponential right here, this guy, equal to another nice number. And let's just pick, I don't know, negative 1 minus x equals 1. So that would give me negative 1 equals 1 plus x, and that gives me negative 2 equals x. Great, so I know I'm looking for a place where x equals negative 2. We plug that into our equation, and we get this. F of negative 2 equals, I forgot my equation, there it is. Negative 3 times 4 to the negative 1 minus, what's x? Negative 2 plus 6. Now the top of that fraction, that exponential is going to simplify because we chose it specifically for the fact that it would simplify to 1. Which means this is negative 3 times 4 plus 6. And that becomes negative 12 plus 6, which equals negative 6. Okay, so x equals negative 2, y equals negative 6. There's my second key point. So where's that on this graph? Well, looks like I did some math wrong. Where is this going to be? Did I write down the equation wrong? Negative 3 times 4, negative 12. Oh, yeah, I think I did something wrong. Back at the beginning of the problem, I was probably talking about negative 6 instead of positive 6. Your horizontal asymptote is right here. Whoops. The thing that clued me into that, and this maybe is a good demonstration, I'll keep this video, it's a good demonstration that silly things happen, and what clued me into the silliness was that I got a key point sitting on what I thought was the horizontal asymptote. That's not great. The exponential cannot touch that horizontal asymptote. It gets real close, see, like this, but it does not actually touch it. So I'm going to hit those 2 points and then ride real close to the horizontal asymptote, and that is it.